Hello, YouTube. This is Mr. Bakari, and today I want to talk about factoring by grouping. This is a popular method that we use in high school math as well as college algebra and beyond. It's just a great way of factoring when you have four terms, okay? So this is a great example. We've got a four-term polynomial, okay? And I want to make sure that it's in order of descending order by exponent and which we would call standard form, right? And there's a little trick that we can use to see if this is going to factor using this method. If you look at the two leading coefficients and then the following two leading coefficient and constant, the ratio of the first two, which is 1 to 3, should be the same as the ratio of the last two, which is 2 to 6. If these ratios are equivalent, then this should work out fine. Okay, so you want to check that first. Now, how do we do this? Well, just like when we're factoring anything to start off with, we want to make sure, can we factor out a GCF? Is there a greatest common factor? Here there is not, so we're going to get to it and we're going to group. So I'm going to group the first two and I'm going to group the last two terms, okay? And so what I want to do is I want to factor out the GCF out of each grouping. So in the first grouping, the greatest common factor is x squared. And that leaves me with x plus 3. So if I distribute back, I should get back x cubed plus 3x squared. And then in my next group, the GCF is 2. So I'm going to pull out a positive 2. And that would leave me with x plus 3. Now, if I do the math right, these two terms should have a common factor, which, as you can see in parentheses, is x plus 3. So I can factor that out, and what I'm left with is x squared plus 2. And that is my factored form. We always want to make sure we can't factor any further, but as you can see here, neither of these can be factored. We are done. Okay? For our next example, let's look at this one, which is also a cubic, 2x cubed minus 4x squared plus 3x minus 6. And again, if it's not already in standard form in descending order of exponent, you want to put that in order. And again, you want to check that ratio that I'm talking about. 2 to 4 is 3 to 6. So 2 to 4 is equivalent to 3 to 6. So this checks out. So we can go ahead and group. So again, we're going to group the first two and the last two. Don't forget, I didn't mention it, but you want to factor out a GCF to begin with, if possible. There isn't one, so let's get to this. So in the first grouping, I can pull out a 2x squared, 2x squared. So that leaves me with x minus 2. Check it, 2x squared times x, 2x squared times negative 2. Okay, always check your work there. Make sure you did the math right. Over here, I can pull out a 3. And like I said before, if you do the math correctly, each term should have a common factor. And as you can see, x minus 2 can be pulled out. And what I'm left with is 2x squared plus 3. Okay, this is the final factored form. I can't go any further with this, and I'm done. Okay. So another common way we can use this and utilize this to our advantage is when we have a trinomial where our leading coefficient a is not 1. Okay, it's not equal to 1. So what we can do is we can expand this into a four-term polynomial and then apply the grouping method. So that's what I'm going to do right now. So we want to start this off looking at A and C and B, A, B, C. Remember, it's a quadratic. That's going to be ax squared plus bx plus c equals y. So when I refer to A, B, and C, I'm referring to the coefficients here and the constant. So what I want to do is I want to take A times C, which is positive 18, and I want to look at factors of 18 that add together to give me 11. Okay? So some of you right off the top of your head might come up with that combination, but you can, if not, you're just going to list the factors. So you got 2 and 9 and 3 and 6. So looking at this, I can see that 9 and 2, when multiplied, will give me positive 18, and when added together will give me 11. So what I'm going to do is I'm going to write an equivalent to this. I'm going to start with my 6x squared, but I'm going to expand this middle term, 11x, into 2x and 9x, and then add my constant there at the end. Okay? Again, you can put the 9 and 2 in any order, but what I was going to say was, again, you want to make sure. And if we did the math right over here, this should check out, but the ratio of 6 to 2 is the same as 9 to 3. So this is ready to be grouped. So now we have a four-term polynomial that we will use the grouping method for. Okay? So my GCF here is 2x, and that will leave me with 3x plus 1. Check it. Okay? And over here, I can pull out a 3. And that will leave me with 3x plus 1 as well. So we're looking good here. Two terms, we've got a common factor of 3x plus 1. So we'll take that out. Oops. And I am left with 2x plus 3. Now don't forget, when we are done and we have our factored form, this should be the equivalent to what we started with up here. So you can FOIL this, you can multiply this out, and you should get back out 6x plus 11x plus 3. Let's check it real quick. Okay, so we can review foiling. So I'm going to take my first times my first times my last, second times first, and second times last. And sure enough, 6x squared plus 9x plus 2x plus 3 is 6x squared plus 11x plus 3, and we got back what we started with. So that's factoring by grouping. I hope this helps you out, and good luck with your factoring ventures in your math class. I'll see you next time.